Good morning to one and all. My name is Reddy. My registration number is 506. Now in this video, I am going to explain about process control block. Now let us get started. So let us start with the introduction to the process control block. So process control block is a data structure in the OS kernel containing the information needed to manage the scheduling of a particular process. So it has other names. They are not, that is, process control block is also known as task controlling block, entry of the process table, task structure, or switch frame. The process control block is mainly described as the manifestation of a process in an operating system. So now let us see what is the role of process control block. So the role of process control block is central in process management. That is, it plays a major role in managing the process accessed and or modified by most operating system utilities, including those involved with scheduling, memory, and input-output resource access and performance monitoring. So the set of the process control blocks are defines the current state of the operating system. Data structuring for processes is often done in terms of process control blocks. For example, pointers to other process control blocks inside a PCB allow the creation of those queues of processes in various scheduling states. For example, ready state, log state, running state, so on, etc. So, in modern multitasking systems, the structure of the PCB is process identification data, process state data, process control data. So let us know about each of them. First, process identification. So data always include a unique identifier for the process. In a multi-user multitasking system, data like the identifier of the present process, user identifier, user group identifier, etc. The process ID is particularly relevant since it is often used to cross-reference the operating system tables defined above. Example, allowing to identify which process is using which input-output devices or which process is using what memory areas. So the second one is process state. So data define the status of a process when it is suspended, allowing the operating system to restart it later and still execute correctly. Includes the content of the CPU general purpose registers. The CPU process status, word, stack, and frame pointers, etc. During content switch, the running process is stopped and another process is given a chance to run. So that means when the content is switching, the process which is currently running will be stopped and the another process will be executed. The kernel must stop the execution of the running process, copy out the values in hardware registers to its PCBs and update the hardware registers with the values from the PCB of the new process. So it should update the values of the PCBs. Now, process control information. So this process control information is used by the operating system to manage the process. So this process control information includes process scheduling state, process structuring information, inter-process communication information, and process privileges. So let us see each of them. First, process scheduling state. The state of the process in terms of ready, suspended, etc. and all other scheduling information as well, like priority value, the amount of time elapsed since the process gained control of the CPU or since it was suspended. Also, in case of a suspended process, event identification data must be recorded for the event the process is waiting for. So now, process structuring information. So process children's IDs or the IDs of other processes related to the current one in some functional way, which may be represented as a queue, array, or other data structure. Inter-process communication information. So various flags signals, and messages. So associated with the communication among independent processes may be stored in the process control form. Now fourth one is process privileges. In terms of allowed or disallowed access to system resources. So this is the structure of the process control block. First one is process ID. So second part is process state and process counter, register information, scheduling information, memory related information, accounting information, status information related to input or output. Now let us see about each part. First, process state. Process state is the second one. So process state. State may enter into new, ready, running, waiting, dead, depending on CPU schedule. So we already know the states in any process are only 5. That is, when a process is new, it is entered into new state. When a process is ready for execution, it is entered into ready state. When a process is already running, it is set to be in running state, and then process is waited due to some input output operations or in some interruptions. It is set to be in waiting state, and when the execution of the process is completed, the process is set to be in dead state. So process number, that is PID, a unique identification number for each process in the operating system, also known as process ID. So process number is also known as process ID. That is, each process in the operating system is given with a unique number, and that unique number is known as process ID. And program counter, a pointer to the address of the next instruction to be executed. So as we have now, in this, one process executes after the execution of the another process. So let us consider there are 3 processes A and B and C. So currently the process A is executing. Then the address of the process B is stored in a program counter. So CPU registers. So CPU register indicates various register set of CPU where process need to be stored for execution for running state. So CPU scheduling information. So this CPU scheduling information indicates the information of a process with which it uses the CPU time through scheduling. Memory management information. So this memory management information includes the information of a page table, memory limits, segment table depending on memory used by the operating system. So next one is accounting information. So this accounting information includes the amount of CPU used for process execution, time limits, execution ID, etc. So the last one is input output status information. So this input output status information includes a list of input output devices allocated to the process. So now let us see the last topic, that is location. So since PCB contains the critical information for the process, it must be kept in an area of memory protected by normal user accesses. So in some operating systems, the PCB is placed in the beginning of the kernel stack of the process, as it is convenient protected location. So that means that PCB contains much information about a process. So the PCB is placed in a very secure location in the operating system. So thank you for your time.